started in a second here. I'm just going to get some things prepped up. These tend to be long. Okay, yeah. Yeah, I just turned it on. I was muted. Sorry. Yeah, we'll go over word problems today. And if you have questions, we'll look at those. I have 3 set up that we'll go through. They do take a while. There is a lot of information in these things, and you really got to be neat and organized when you go ahead and put them out. So we are going to start with probably the simpler of the ones, which is this one right here. But again, remember, we are solving a system of equations here. So we know that there are going to be 2 equations to write from this. Okay, so we have 2 equations. And we also know that we have 2 variables. So the first thing you're going to want to look at is defining those variables. You want to tell me what you mean by your variables somewhere, because a lot of times it's easier to use the letters that are provided so we can keep track of what's going on. However, you're more than welcome to use X and Y every time too. But first we want to define variables. So step 1 here for word problems is define your variables. And that's as simple as saying, hey, this variable equals this quantity. This is what I'm measuring from it. So let's read our problem. This is our example. The sum of Ellie's age and Cecil's age is 60. 6 years ago, Ellie was 3 times as old as Cecil. Find Ellie's age. So we're going to go ahead and define variables here. I'm going to use capital E to represent Ellie's age. And I'm going to use capital C to represent Cecil's age. That's defining my variable. So now I know what I'm actually going to be solving for, and I know what they're going to mean. Again, you could have named them anything you wanted. I just went with E for Ellie and C for Cecil, and I kept them capital so I don't get confused with other math notation that might be out there. And then I'm going to look at it, and I should be finding 2 equations. So step 2 is write your equations. You got to be able to pick them out. And it tells you kind of in this one what's going on. It tells you that the sum of Ellie's age and Cecil's age is 60. Now remember, sum means to add. So I know Ellie's age plus Cecil's age should be 60. So my first equation is going to be Ellie's age plus Cecil's age equals 60. I know that's true. However old Ellie's is, and E stands for Ellie's age, C stands for Cecil's age. Add them together, it equals 60, because sum is telling you to add. It also says that 6 years ago, so 6 years ago from now, Ellie was 3 times as old as Cecil. Okay? So Ellie is 3 times as old as Cecil 6 years ago. So 3 times, or I'm sorry, Ellie is 3 times, I'll write it as words, is 3 times as old as, or as, was it Cecil? Cecil 6 years ago. So just looking at that, you can probably pick out your second equation, which would be, let's see how I want to do this. 6 years ago, Lily was 3 times. So we have to subtract 6. So this is looking at subtraction of 6. This is Cecil's age. And it is 3 years ago. Equals Ellie's age. And I'm just kind of pulling it out of what it means. So basically I'm going to take Cecil's age, right? I'm going to subtract 6 from it, and then I'm going to multiply it by 3 to get Ellie's age. That's what it's saying. 6 years ago, Ellie was 3 times as old as Cecil. So take away the 6 years, and I'll subtract the 6 years from Cecil and multiply it by 3. So that's my second equation. The second equation sometimes is difficult to pull out, sometimes it's pretty easy, but it's just going to come with practice. So I know that Ellie's equals 3 times C minus 6. I don't need that. So I got my 2 equations. You're more than welcome to distribute this out. Just remember that this C minus 6, you're taking away those 6 years first, right? 6 years ago, this was true. It's not this is true plus more 6 more years or minus 6 more years. It's 6 years ago, this was true. So 6 years ago, 3 times whatever Cecil's age is minus the 6. So you do want to do the subtraction of 6 first there. You can go ahead and distribute that out if it is more comfortable to you, because that way it's gonna look more like that y equals mx plus b, which we might as well do. So this is going to be equal to 3c minus, and then right, 3 times c gives you 3c, 3 times negative 6, don't lose that negative, gives you negative 18. So you can look at it that way as well. I'll just stick the e on that side. So you can look at it as this and this, or if you want to use that, that's fine too. Either way, it's going to work. So we wrote our equations. Now we should be at where you know how to do it. That's the new part, is getting the equations out of there. And it takes some reasoning and it takes some practice. Just kind of read carefully and see what it's actually saying. And we'll do some other examples. And as it gets on, it tends to get easier. It really does, the more you do it. The ones I gave you really aren't too hard. They're just kind of big numbers. So once you get past the fact that, hey, we got big numbers happening, it's pretty much the same thing. So we can go ahead and do step 3, which is our actual solving. So here, that was just our setup. Here we're going to solve. And for step 3, we solve by substituting first. So you can pick this one here to plug into here, or this one to plug into there. And again, I'm going to get rid of this. I'm not going to use that. You're more than welcome to use that one. But 3c minus 18 equals e is the one I'm going to use. And what I'm going to do is I'm going to substitute this in. I know what e equals. It tells me right here. So I'm going to go ahead and substitute it into this equation here. And I'm going to get 3c minus 18, which is e. So I'm going to substitute that for e. Again, you can put parentheses there just to keep things organized, but in this case they're not needed. Right, get in there, then you can sit there and combine like terms. So 3c and c can get 4c minus 18 equals 60. Add 18 to both sides. So we did the substitution. I guess step 4 would be combined like terms. And step 5 is solve for a variable. So here I am solving for Cecil's age, because remember C equals Cecil's age. So 60 minus 18, I guess if you want to put the line there. So 4c, 60 minus 18 gives us 42. Divide by 4, divide by 4. 42. Cecil is looking like, did I do that right? Yeah, Cecil is looking like she is getting a fraction here, which doesn't make sense to me. So I'm going to double check my work before to see what I did before to do this, if I made a mistake. C minus 18. Oh, that's what I did wrong. I read this wrong. Ellie was 3 times Cecil. I subtracted 6 years from Cecil's age, but not Ellie's age. I got to subtract 6 years from both ages, because when there's 6 years ago, you're going to go down both ages. That's why I'm getting something weird. So again, it takes a little reading here, which is not my strength. So let's get that second equation for again. All right, let's relook at that. So 6 years ago, so 6 years ago, Ellie was 3 times as old as Cecil. So Ellie is 3 times as old as Cecil. Right, so Cecil times 3 is going to be Ellie's age. And that was 6 years ago, so I'm subtracting 6 from both sides. So I'm subtracting 6 from both sides. That's where I screwed up. I took the 6 years off of Cecil's age, but not the 6 years off of Ellie's age. In that case, you can distribute that out. It's still going to equal Ellie's age minus 6 equals 3c minus 18. In this case, we can add 6 to both sides. And now we actually get our Ellie's age equals 3c, and then 18 plus 6 gives us 24. Oh, it does. That's signs are different, so that gives us a minus. Is it 12? I think that's where we're at. Let me double check my notes from earlier. Yeah, that's where we're at. We should be at that. So I'm going to go ahead and write that up here. E equals 3c minus 12. Okay, now we can plug in. We get 3c minus 12 plus c equals 60. Again, I'm substituting in this e for this e. That's all I did. Just wrote that, which is right there in front of all of that. Combine my c's to get 4c minus 12 equals 60. Hopefully this is going to make more sense. Add 12 to both sides. You get 4c equals 60 plus 12 is 72, which is divisible by 4. 72 divided by 4 gives us 18, so c equals 18. So I know Cecil's age is 18. So over here, I'm just going to write 18. I know that's Cecil's age. I figured out Cecil's age through all of this. I just need to get Ellie's age now, and that's pretty simple by substituting back into one of our equations. So solve for the variable, then 6 is substitute back in. Substitute. I don't know how to spell that, back in. One of your original equations, and this one's probably going to be the easier one to use here. So I'm going to type c as 18, plug it in, so Ellie's age plus 18 has to equal 60, and in that case you get minus 18 and minus 18, and this is your 42. Right, 60 minus 18, just checking my work. Yeah, that's your 42. Ellie's age is 42. And then they are years old. So 42 years old and 18 years old. Again, hardest part today is where I messed up, is reading and trying to get things situated and organized there. Let's do another one. That one actually was probably one of the harder ones because of the way that the equation comes out to be. Let's get rid of that. Let's look at, is this the hot dog one? Yeah, this is hot dog. Hot dog one's easy. Just get rid of all that. So again, first we have to define variables. So we're going to read this through and see out what, should we do the first one in the Google Docs next? Can we do the first one? No, we're doing this one next. This one, and I think the first one, I don't even have the Google Docs open. I got to open that. You'll be able to figure them out based on this one probably. The age one was a bit tougher than I kind of thought, but nah. I'll get to it. I have to open the Google Docs here. Okay, let's look at this one. We are running a concession stand at a basketball game. You are selling hot dogs and sodas. Each hot dog costs $1.50, each soda costs 50 cents. At the end of the night, you made a total of $78.50. You sold a total of 87 hot dogs and sodas combined. You must report the number of hot dogs sold and the number of sodas sold. How many hot dogs were sold and how many sodas were sold. So first off, we're going to define our variables. We're going to say H equals hot dogs, and we're going to say S equals sodas. And just picking out information, I'm looking at this line here. At the end of the night, you made a total of $78.50. Actually, no, I'm not looking at that line yet. I'm looking at, you sold a total of 87 hot dogs and sodas combined. So that I know my hot dogs plus my sodas have to equal 87. That's how many numbers amounts I sold. My other one I need to know was what I first underlined. And that's coming from this section here. I made a total of $78.50. So I need to know however many hot dogs I sold. Hot dogs sold and sodas sold has to come out to a price of $78.50. And you know each hot dog is $1.50. So that would be the number of hot dogs I sell times 150, because I want to make everything into money, plus however many sodas I sold times 50 cents. 0.50 has to equal $78.50. So this here is your next equation. We're going to clean that up though. I'm just going to write it as 150 times H plus 0.5 S has to equal 7,850. And those are your two equations. A little easier to pick out on this one. Right? Hot dogs times however much they cost plus sodas times however much they cost have to equal however much you actually made. Let's get this S and 5 a little cleaner. This is a 5 and this is an S. So with that, you need to solve for one of these because neither one of these has it equal to a variable. So this one here is probably easier to solve for. And it doesn't really matter which variable you solve for. It's just going to determine which one you're going to find first. So let's go ahead and solve for hot dogs, I guess. So I'm going to come over here and say H plus S equals 87. So I'm going to solve for H. So I'm going to subtract S from both sides. So H equals 87 minus S. That's an S, not an 8. 87 minus S. So I'm going to come over here and I'm just going to draw off here. This says H equals 87 minus S. They are the same equation. They're just written to solve a different variable or a different quantity. So now I know what H equals. I can go ahead and plug it in. Just watch your parentheses here because you are going to be multiplying by H, and H is this whole value, not just the 87. So you got to make sure you multiply by all of it. Plus 0.5 S equals 78.50. Now go ahead and distribute combined like terms and solve for S like we were doing last chapter. So here we're going to take 150 times 87. 1.5 times 87, we're going to get 130.5 minus S, which is 1.50 S, because again we're going to multiply that by that as well. We're going to add that to 0.5 S, and that's all going to equal 87.50. Then you are going to combine like terms. So 130.5 is not a like term. This is a negative 1.50, so a negative 1.50 plus 0.5 is going to actually subtract that, so that's going to be negative 1. S, don't lose your variable, equals 78.5, so I'm going to go ahead and this is a positive, so I'm going to subtract it. So subtract 130.5, subtract 130.5. I'm going to get negative 1s. Again, you probably don't need the 1. We'll just call it negative s equals 78 minus 130.5, 78.5 minus 130.5 gives me a negative 52. So my sodas, a positive S, is going to be a positive 52. So I know my sodas were 52. So I sold 52 sodas. Once you get your sodas, you plug back into one of the other ones to solve for your hot dog. Might as well do the first one here. In all honesty, as long as you're confident in the way you transform things, you can use this as well. But we'll plug into that. So I know H plus S, which is 52, equals 87. So subtract 52, and you get H equals 8 minus 5 is 3, 7 minus 2 is 5 equals 35. So you did 35 hot dogs. Any questions on that one? Again, all of this is the same stuff you've been doing. It's just writing the equation from the word problem. That's going to take some practice. And we did a little bit of that earlier this year too. All right, I can look at problem 1 on the thing here. I didn't put it up. Let me get it up here. Let's see. Don't want that. Don't want that. Want that. Equations for getting this one isn't too bad because they're the formulas. As long as you know your formulas, you should be good. Length of a rectangle is 5 centimeters more than twice the width. The perimeter of the rectangle is 34 centimeters. Find the dimension. So when it comes to geometry, it helps by drawing pictures. So let's draw a picture of a rectangle here. Here's our rectangle. We know length goes with the longer side, so this is length. We know width goes with the shorter side, so this is width. And we have a perimeter here. So I'm going to say perimeter. And it tells you the perimeter. The perimeter of the rectangle is 34 centimeters. And it's asking for the length and the width. So what are the length and the width of this perimeter? Well, it gives us some information. It says the length of the rectangle is 5 centimeters more than the width. So length equals 5 centimeters plus whatever the width is. So there's your first equation. And it says the perimeter of the rectangle is 34 centimeters. Now you don't know any other information, but technically you know how to find perimeter. At least you should. You should know that perimeter, and honestly there's 2 ways to look at this. You know perimeter is going to equal 2 times your length plus 2 times your width, because that's the formula for perimeter. Or if you just know the definition of perimeter, you know that perimeter is going to equal length plus width plus width, which again, if you combined like terms, would get your formula for it. So we are going to use that as our second equation, but we already know what P equals, so I'm going to substitute P into it. So P is 34, so that's going to be 34 equals 2L plus 2W. And we also know what L equals. Not exactly what L equals, but we have something that equals L. So let's go ahead and substitute that in for L as well, because that's going to be our 2 equations. We're looking at this equation, and we're looking at this equation. So we got our 2 equations out of it. Let's substitute in for L. So I got 34 equals 2, and again this is times, so it's the quantity of whatever this is. 5 plus W, and then plus another 2W. So once you substitute in, you can distribute 2 times 5 and 2 times W, so 34 is going to equal 2 times 5, which is 10, 2 times W, which is 2W, And then you're going to add another 2W to it. Keep bringing on. Now combine the like terms. So this was distribute. We're now going to combine like terms. I can add my W's together. So 34 is going to equal 10 plus 4W. And then I can solve for W. This is just going to be solve for W. I'm going to go ahead and subtract 10 from both sides, and I'm going to get 24 equals 4W. I'm then going to divide by 4 and divide by 4. 24 divided by 4 gives me 6 equals W. This will cancel, that'll cancel. So here I know 6 is W, so W equals 6. Once you know what one of them is, you can plug back into really either of your formulas to solve, but this one here is going to solve for length anyways, so we might as well plug it into here. So we're going to get L equals 5 plus W, and we know W is 6, so L equals 11. This equals 11, and we have units. Everything is in centimeters here, so we're going to say centimeters and centimeters. So these are your dimensions. Oh, sorry. I guess we'll say this equals L, so it's over there. This is L, and this is W. Is there any questions on where anything came from? All right, so L and W down here, these are your answers. Any questions on where we got any of this information? One, it was implied that you knew the formula, so hopefully you got the formula down. Other than that, reading it wasn't too difficult. The length of the rectangle is 5 centimeters more than twice the width. Oh, I screwed that up. I didn't say twice the width. There should be a 2 there. I'll do this again. I didn't read right. I'm not very good at reading, if you haven't noticed. We'll do it again. So Luke might be right there. We have a width, and we have a length, which is 5 centimeters more than twice the width. So twice the width plus 5. Sorry about that. So we'll do it again. I'll do the next one next. It's not too difficult either. I just can't read. I'm having a rough day reading today. So it is twice the width, so 2 times the width plus 5. And we still have a perimeter of 34, and we still know that perimeter equals twice the length plus twice the width. So in this case, you're going to substitute into this guy here, into our formula. So you're going to get 34 equals 2 times 2W plus 5 plus 2W. Go ahead and distribute the 2 out, and you get 34 equals 4W plus 10 plus 2W. Go ahead, combine like terms, and you get 34 equals 4 plus 2 gives you 6W plus 10. Subtract 10 from both sides, you get 24 equals 6W. Divide by 6, and you get 4 equals W now. So our width is actually 4 here because it was twice the W, which, yeah, is what it is, I guess. I just read wrong. Sorry about that. And then we'll plug back into our original one here. So L equals 2 times 4 plus 5. 2 times 4 is 8 plus 5. So L equals 13. So here your width is 4, length is 13. And oh, sorry, centimeters. Don't forget your units. So sorry about that. Hopefully you didn't go with the first one, but it is twice the width, so I did make that mistake. We'll look at the next one. And just get a little bonus one in there, I guess. Alright, this one's a little tricky. I'm just trying to figure out what it's asking. Once you figure out what it's asking, it goes pretty easy though. So we're looking at, suppose you're thinking about buying one of two cars. You have car A and you have car B. I'm just going to pull out information. That's A. Car A and car B. You know car A will cost $17,655 up front, and you expect to pay plus an additional $123 per month. Right? Is it month? No, per year. Yeah, that's a lot per month, per year. So we're going to multiply by the number of years you have. That's pretty much what it's going to say. We're going to say y equals years. I'm not exactly sure what it's asking. I didn't get that far yet. Car B costs $15,900 plus an additional $1,424 per year. Okay, and I want to know how many years are the total costs of the car the same. So what value is there when these two things are equal? And that's really all it's asking. So this is what car A equals, and this is what car B equals. When they equal the same, how many years goes by? So I want to say, hey, when does A equal B? At what time does A equal B? So I am going to set them equal to itself. So 17,655 plus 123y equals 15900 plus 1424y. I want to know when they are the same, so I'm going to say how many years is it going to be when these two are exactly the same. So once you get your two equations, which the equations are pretty simple to pick out here, hopefully. That wasn't much the issue, but the numbers are kind of big. We're just going to combine like terms. So you can either bring the 1230y over or the 1424y over. I'll bring this one over just to keep things positive. So I'm going to subtract 1230y from this side and subtract 1230y from that side. Again, whatever I do to one side, I do to the other. This is going to cancel. Leaves me with 17655 equals 15900 plus, and then go ahead and bring out your calculator for, unless you want to do that by hand, which actually isn't too difficult. 1424 minus 1230 is going to give me 194y. Then you go ahead and just solve it. So we're going to subtract 15900 plus 15900. We're going to get 17,655 minus 15900. I'm going to get 1755 equals 194y, and then divide by 194, divide by 194, and we are going to get a decimal here if I recall. Divide by 194, yeah, and it's going to be 9.046 something equals y, so you're going to round that. How many years is that? That's going to be 9 years. So it's about 9 years. And that is your answer. I'm not in my face, am I? No. Okay. Alright, so that one's not too difficult. Again, it just comes with practice. Any questions about anything? There's only a couple of you left tuning into this, which is a little disappointing, but thanks for sticking around. This is definitely a topic that will be covered a lot more in depth next year, so we are just kind of... Oh, I definitely took it a lot further than your book did, but you will get a lot of this again next year. So keep that in mind. If there are no other questions, I'm going to go ahead and end it because our time's pretty much up anyways. If you do have further questions, shoot me an email. I'll try to get back to you.